welcome to physics class. If you're taking physics, it might be that your first question is, well, what is physics? Physics is the study of matter, energy, and their interactions. The goal of physics is to be able to describe the physical world around us with mathematical theories that have been motivated and supported by experiments. Now keep in mind that this word theory in science has a different meaning than the word theory in everyday language. And in particular in physics, the word theory has a really specific meaning, really technical meaning. A theory is a mathematical statement that gives you predictions and descriptions of how the physical world works, and this theory has been supported by lots and lots of evidence over a long period of time so that people have a high degree of confidence in its ability to explain nature quantitatively. A theory is not just a guess or speculation. A theory is not a hypothesis. A theory is a mathematical explanation that has a lot of supporting evidence, and we are certain that it works to a certain degree of precision. So a theory is not the final explanation. It's not 100% certain. In physics, theories kind of work within a certain realm of applicability. A classic example of this is gravity. So Isaac Newton came up with a theory to explain gravity. We also call it a law of gravity. And it works really, really well under most normal circumstances. It works incredibly well to explain how objects fall on the surface of the Earth. It works well to explain the orbits of planets around the sun. We can talk about the forces between the Earth and the Moon and describe the Moon's orbit. It turns out that this theory doesn't work so well anymore when you move at really, really high speeds, close to the speed of light, or deal with really, really dense, highly gravitating objects like black holes. And that's where Einstein came along, and he came up with the theory of general relativity, which is broader. And so in some sense, Newton's gravity is wrong, but it's not really wrong. In physics, theories apply under a certain set of circumstances, and as long as those conditions or circumstances are met, they work really, really well to describe nature. So when we send rockets to Mars, Newton's gravity works perfectly well to explain that rocket motion. So in this class, we'll be learning several physical theories and laws. These will involve concepts like force and velocity, acceleration, and they can be expressed in terms of fundamental quantities like length, mass, and time. So over the course of chapter 1 and 2 in the textbook, the first few weeks in this class, we're going to develop some mathematical tools for dealing with time and length and mass and describing motion.